Hello and welcome to my video on R programming. In this video, we'll learn about the data types used in R. So let us start with the vector data type. So what are vectors? These are single dimensional array. Okay. So whenever there is a data set which contains a number of values in a array, we can say that we can assign it to a vector. We can say x equal to c 1 2 3 4. So in this case you can see that the value of x is 1 2 3 4, which is a single dimensional array, and this vector is called a numeric vector. Okay, now suppose you want to have a character value in the vector, so you will say C inverted commas US UK, and these type of vectors are called character vectors. Okay, now suppose you want to have boolean values in your vector, you can say true and false. So these type of vectors are called boolean vectors. So let me just run this. So you can see that the values has been assigned to x, y and z. Okay, so the next one is the scalar vector. Scalar vector is a single element. Okay, so a scalar data type is a single element, and you can assign it the value as in the same way, just the concatenated operator will not be there and it will have just a single value. So these are scalar data types. Okay, and if you want to access the vectors, you can do x1, or suppose the second one you want to access from this vector, you can do x2. So once you do x2 and you run this, you can see that the value of position 2 is being printed. Okay, now suppose you want to print the values from one position to the third position, you will do x1 is to 3. Okay, so in this case we are talking about the vectors. Scalar, it's only one quantity, so there's no point of accessing a different position, it's just only one position. Okay, so the third one is the matrix. So a matrix is a 2D array. So it will contain rows, it will contain columns, and when we don't assign the b by row is equal to true, then by default the matrix is assigned row wise. Okay, and if we say by row equal to false, then it is assigned column wise, and if we do not specify anything, it will by default be arranged column wise. Okay, so suppose we have a vector, it's a variable, we say it's 1 2 3 4. Okay, and now we say that f0 is matrix vector. This is the vector which you want to display as a matrix, and now we say that n row is equal to 2 comma n column is equal to 2. Okay, now we say by row is equal to true. So in this case Okay, we did not run this. So let us just first run this, and now we can say that the vector has been assigned, and now we'll run this. So you can see that the F0 has been assigned and it is a matrix. And you can see the matrix as this, and you can see that the values has been assigned row wise. It's 1, 2, 3, 4. Okay, and now let us do the same thing, and let us create another data set and say by row is equal to false. Okay, let us just run this, and we can see the F1 values, and it is arranged column wise 1, 2, 3, 4. Okay, so when we say by row is equal to false, it will arrange it column wise. Okay, now how can we access these vectors? Oh, sorry, these matrices. Okay, so let us name this variable mat, and we say matrix C 1:4, comma, in row is equal to 2, comma, in column is equal to 2. So when we run this, we will see that the mat value has been assigned and it is arranged column wise. Okay. So this mat variable has a matrix which has a values from 1 to 4, and it is the rows is 2 and the column is 2, and we have not defined by rows, so it will automatically arrange it column wise. Okay, so suppose we have to access some elements from this matrix. What we'll do, this row will give you the first row. Okay, then you say this first is empty, the row is empty, so it will give you the first column. And now this 1, 2, it will give you the first row of second column. Okay, so let us just run this and see what we get. Okay, so it will give you the first row, and this will give you the first column, and this the first row of second column. Okay, sorry, the first element of second column. Okay, now we will talk about the arrays. So the arrays are multi-dimensional elements. Okay, suppose we declare one vector, vector 1, C as 1, 2, 3. Okay, and we declared vector 2 as C 10, 20, 30, 40, 50, and 60. Okay, and we say result array C vector 1, comma vector 2, comma dim is equal to C 3, 3, 2. So what this dim does is, dim always specifies the rows, columns, and the matrix. Okay, so in this case it will take the result of vector 1 and vector 2, it will concatenate it according to the condition which are given in dim. So dim says that it should have 3 rows, 3 columns, and 2 matrices. Okay, So let us just run these two first. Okay. Object. Okay, sorry. Now, so vector 1 and vector 2 has been assigned, and now is the result. So now the result has been assigned. If you want to see what has been assigned to result, you have to do print result. Okay, so here you can see that it has 3 rows and 3 columns and 2 matrices. Okay, so this dim condition will tell you that, will tell R to print it in that order. Okay, so suppose we want to print the result according to the rows and columns. So when we say 3 comma 2, 3 comma, and this is 2, it will return the third row of second matrix. Okay, because the first one is row, then is column, and then is matrix. Okay, now let us run this. So you can see that the third row of second matrix has been printed. Similarly, we can print different combinations. So this concludes some of the data types used in R, and I'll be back with my next video shortly. So till then, bye bye.